I am live. This is Math 60, section 4.3. This is page 3, fully into the heart of darkness. Uh, this is the hardest part about math was not bringing the alphabet in. The hardest part about math is when we take two completely different subjects, such as absolute value and an inequality, and we mix them up and we try to do them together because why not? Why not do all the pain at once? So here's the thing. Again, let me point out that this is a really specific little piece of math that is going to be really, really important if you're going on to calculus. But for those of you who are not planning to go on to calculus, please be really gentle with yourself. Everyone should be really gentle with themselves and understand that some of these things are going to take a couple of tries to understand. It's possible that some of you are just going to get this right off the bat. If that's awesome. It's possible that I'm just an amazing instructor and everything makes perfect sense, and that is awesome. And it's also possible this will be deeply frustrating. And I'll remind you, when you're trying to get through the homework, be prepared, take breaks, send me pictures if you're getting stuck. We can work on things together via text, via email. Okay, having said that, let's see how this goes. Okay, dum dum dum. So interestingly enough, instead of just going straight into the formula, which there is a formula in the book, it's a lovely formula, you can memorize it. I'm actually going to recommend that we do this instead by just randomly trying answers. So I want to know when the absolute value of x is less than 4. So I'm going to plug in values. So for example, I already wrote yes. Let's look on at y. And in fact, I think I want to bring this in a little bit further. And let's look at what's going on. Here, the absolute value of 0 is 0, which is less than 4. Yep. The absolute value of 1 is 1. Is that less than 4? Yep. So this is a yes. Okay, the absolute value of 2 is 2, which is less than 4. Yes, remember we're looking for things which when we take the absolute value, it stays less than 4. So let's say yes. 3, yes. 4, whoops. The absolute value of 4, is it less than 4? No. It's equal to 4. So if we had an equals there, we would be able to include it, but we don't. How about 5? No, 5 is way too big. Absolute value of 5 is 5. That is way too big. It's bigger. Oops, bigger than 5, bigger than 4. So the numbers 0, 1, 2, 3 all work. The number 4 does not. Let's go at negative land. The absolute value of negative 1 is 1. That's less than 4. Yep. Absolute value of negative 2 is 2. That's less than 4. Yep. Absolute value of negative 3 is 3. That's less than 4. Yep. Absolute value of negative 4 is 4. That's equal to 4. So it's not a solution. The absolute value of negative 5 is 5. That's bigger than 4. That's not a solution. Okay, so let's look on a number line what's going on. I got positive 1, positive 2, positive 3, positive 4, positive 5, negative 1, negative 2. It helps if you do it sing-songy. It sounds less scary. Negative 4, negative 5. Like, it's no big deal. Now, imagine that these are all evenly spaced when I show you, because I didn't evenly space them perfectly well. Okay, so let's see which values. 0 is definitely a point. 1, 2, 3, not 4. Negative 1, negative 2, negative 3. That's interesting. All the points that work are on the inside, closest to 0. The numbers which do not work are on the outside. And in fact, we can think about larger numbers like 10 or 100. Absolute value of 10 is 10. That's way too big. How about negative 10? Absolute value of negative 10? Again, 10, way too big. Now, I didn't actually talk about any fractions, but could I convince you pretty quickly that a number like 1/2 or 1 3/4, the numbers in between all of these values, or maybe even numbers like pi that are irrational, as long as the number is smaller than 4 and greater than -4, I claim it'll work. So think about that. And in fact, I think the numbers all the way up to, but not including 4 and -4 will work. So what do I mean by that? I mean like this. So remember we talked about absolute value having coming at it from both sides. So from both sides, basically this means I have to stay inside this boundary. So for the absolute value of x to be less than 4, I have to stay inside. Now, when would the absolute value of x be greater than or equal to 4? Let me pull myself out a little bit so we can see all of this together. How are we doing? We're doing okay. So if that's -4, that's 0. Uh-oh. Remember the rule, if you have more than 2 numbers on, you have to make sure they're about the same spacing. I claim if I want the absolute value to be bigger than or equal to 4, I start at 4 and I go out. I can either have it be a very large positive number, or I could have, and here is where English deserts us, because if I say a very small number, that's kind of inadequate. So I might say a negative number to the left of -4, or a large and negative number, because we kind of, small usually means close to 0, not really negative. But can I convince you that if I want the absolute value of a number to be greater than or equal to 4, I have to go in either direction, like out to like -5, -6, -7. Because when I get the absolute value, that's going to take off the minus sign and give us that +6, 7, and that's bigger than 4. So notice we've set up a situation where if the absolute value of x is smaller than a number, I want to stay in close. And if the absolute value of x is bigger than a number, I want to stay out to the sides. Which, this always reminds me, if you're young, you have to stay in close. And as you get older, you want to get as far from home as possible. Okay, having said that, and I have not given you a formula at all, we're just going to approach the next problem. You guys ready? I mean, I don't know. You might be screaming, no, we're not ready. Don't do this to us. And I can't hear you. That's the great thing about videos. So I apologize if you're in great amounts of pain, but you know, I got to earn that toaster some way. So we have to solve this thing. Here's the way it works. I've got an absolute value. I've got an inequality. I've got a number. What I'm going to do is I'm going to solve the equality first. So what does that mean? Step 1. Solve the related equation. The absolute value of 3x minus 2 equals 4. So I did exactly the same thing on both sides, just an equals in the middle. Okay, so this we solve 2 pieces. 3x minus 2 equals 4, or 3x minus 2 equals -4. Add 2, add 2. 3x equals 6, so x equals 2. So if I plug in 2, I get 3 times 2 is 6, minus 2 is 4. Absolute value of that is 4. Easy peasy. Okay, so let's come over here. Plus 2, plus 2. 3x equals a somewhat unsatisfying -2. So x equals a -2/3. Not my favorite number. So what happens if we plug this in? Well, if it's -2/3 gets plugged in there, 3 times -2/3 will give me that -2. Minus 2 is -4. Absolute value is 4. So my two endpoints, x equals 2, x equals -2/3. Here's -2/3. Here's 2. I'm totally cheating by not, I'm cheating by not showing it to you. There we go. I'm cheating by not putting 0 in. Keep in mind 0 would be like here. I really want to focus on these two numbers. My two boundary numbers are -2/3 and 2. Here's the thing. This is the point at which each of these values gives this expression, the absolute value of 3x minus 2, will give us equal to 4. We've got a less than or equal to here that we're trying to solve. So we need to stay small. Small. If we're going to stay small, we stay inside. This is a less than or equal to. So what we want to do is we mark these as being brackets and we stay to the inside. What do you think? This is kind of weird. Now, note where I have no room for a note. I'm going to put it right over here. Note. If I had said 3x minus 2 in absolute value is greater than or equal to 4, I would do all the same work. I'd end up with -2/3 and 2. And where would I go with this? If it's greater than, you want to stay to the outside. You want to stay big. So we're going to go this way to the left, get big, and this way to the right. Notice how these complement each other. This is the smaller, and this is the bigger. Okay, what do you guys think? Kind of, sort of? Woohoo. Okay, that's page 1. You guys are doing it. That's page 3, but this was page 1 of the hard stuff. We got one more page and then we're done with the section and then we get to chapter 5, which is so much more fun. No, this is totally fun. What was I talking about? What? I meant this is the most fun thing you'll ever do. So in 5 seconds, I'll see you for a last page of the most fun thing ever in math. Woo!